Sir, one thing when you are starting any topic, no, just check with the kids how much they know. So what will happen if they know in depth, then you can just breeze through, like you just cover a little bit if they know already. In that case, we can move faster. Or if they don't know, then you can go into detail and with the example how you were explaining, you can do that one.
Okay.
So let's start and she can join in.
Okay. Today will we cover physical quantity like scalar and vector and fundamental quantities, unit, symbol in SI system, distance and displacement. In last, we will practice question. First, we understand what is physical quantity. The quantity which we can measure and express in the terms of number and unit. Example, length. Length we can measure time, mass, etc. These are the physical quantity which we can measure. Length. Length can be measured in the terms of meter. Time can be measured in the terms of second. And mass can be measured in the terms of kilogram. Now, physical quantity are two types. One is scalar, another is vector. Is there any doubt in this page?
No.
No, sir.
Good. Now we discussed about scalar. Scalar quantities are those scalar quantity are those which have magnitude and unit. Magnitude means numerical number. Numerical number like 1, 2, 3, 4, 5, etc. These number is called magnitude. And unit means if we measure length, then length is measured in the terms of meter. This represent meter is unit. Kg. It is also a unit. Liter, etc. Scalar quantity means those who have a magnitude and unit is called scalar quantity. Example, and later I will give you example. First you understand what is vector quantity. Vector quantity are those vector quantity are those which have magnitude, unit, and direction. The new word is add direction. There is a major difference, there is a minor difference in scalar quantity, only magnitude and unit have. But in vector quantity, magnitude, unit, and direction. Listen, if we say, example, if we say there is a boy and we say that run 10 kilometer or 10 meter, but we don't tell in which direction you have to run. Listen, they can run in the direction of east, in the direction of south, in the direction of west, and in the direction of north. Whenever we don't say that you have to run in the particular direction, that become a scalar quantity. For example, time. Time is a scalar quantity because in time, suppose that I said 6 o'clock. It means is the number, means magnitude, and time is measured in the terms of second. This is the unit. Same cheez, 10 is the numerical value, means magnitude, and meter is the unit. I hope you are understand what is a scalar quantity now.
Yes. Yeah.
Same in vector quantity, we said vector quantity are those quantity in which have magnitude, unit, and direction. Example, there is a boy and I said you have to run 10 meter in the east. There 10 is the magnitude, m is the meter, means unit, and east is represent the direction. In vector quantity, we have a direction particular where we have to run or where we have to move. For example, for example, I want to purchase sugar from shopkeeper. We give the full information about to shopkeeper. We do not say give 10 sugar because this statement is incomplete because 10 is the magnitude. There is no unit, no unit. Isn't it clear?
Yes.
If we
Yeah.
say,
Yes.
if we say I want to purchase 10 gram or 10 kg, this is the perfect statement or complete statement because 10 is represent magnitude and gram and kg represent the unit. It's clear. I think is it clear?
Yes.
Example of scalar quantity. Distance, mass. Mass also a scalar quantity because when we measure a mass, it's like a 50 kg on weighing machine or 20 kg, 30 kg. So this is the number which represent the magnitude and this is the unit. Same. Uh, time, work, energy, density, etc. But there is a special case. There is a special case, electric current. Electric current is a scalar quantity, but it have magnitude, unit, and direction. Then, then also it have a scalar quantity. Reason why it is scalar quantity, because reason because it does not follow the vector law of addition. It does not follow the vector law of addition. Later I will explain what is vector law of addition. Suppose that this is the wire, there is a flow of electron is obviously was there is a wire have some length, and this is the direction, east and south. Even we say that if the wire pulled upward side, so this is the direction north. Example of vector quantity, example, velocity, displacement, acceleration, retardation, etc. It is not necessary if someone has these three terms, magnitude, unit, and direction. They always a vector quantity. If so, how can we define a vector quantity? Vector quantity is these are compulsory, but vector quantity is also defined for it follow the it follow yeah it obeys the vector law of addition. There is the representation of vector. See, representation of vector. A, this. This arrow represent this arrow represent direction, and rest of length is represent magnitude. So this is a vector. This is a representation of vector. What is vector law of addition? For example, scalar addition is this scalar addition. We know that 3 plus 5, yeah, 3 plus 4 is equal to 7. This type of addition is called scalar addition. But if we say a boy moves 3 meter in the direction of east and 4 meter move in the direction of north, 4 meter in the direction of north, then what is the resultant? So we apply the vector law of addition. In vector law of addition, we know how to solve hypotenuse. This is the hypotenuse square, hypotenuse. This is the perpendicular and the base. We use the Pythagoras hypotenuse square, perpendicular square plus base square. So hypotenuse under the root p square means 4 square 16 and 3 square 9. Then become the value of h is under the root 25. The square root of 25 is 5 meter. This is the vector law of addition. In a scalar, when we add 3 or 4 is equal to 7. When we add in vector addition, when we add 3 or 4, it become a 5. I think now you can understand what is vector law of addition. In vector, this is a tail and this is a head. I think now is everything is clear. Is there any doubt regarding this?
No.
Before moving ahead, sir, I know that there will be some question on saying the difference between the scalar and vector. So if you can give some differences, like right in the mind, because they understood the concept, but when it comes to writing, and that becomes like, what is the distance? What is the difference between distance and displacement? It's the
Ma'am,
same thing, scalar
late,
and vector. If you can give
later,
that.
later I will explain. I have approx 20 questions
Okay. Okay.
regarding this. Uh, this is a special case of scalar quantity. Now we move a fundamental quantity. What is a fundamental quantity? There are two types of quantity. One is fundamental, another is derived. There are two types of quantity, fundamental and derived. There is the 7 fundamental quantities like length, mass, time, temperature, luminous intensity, electric current, amount of substance. These are the 7 fundamental quantities. Unit, quantities, unit. Length we measure. Length unit is meter. Mass in kilogram. Time in second. Temperature measure in Kelvin. Luminous intensity measure in candela. Electric current measure in ampere. And amount of substance measure in mole. Symbol. Meter for small m, kilogram for kg, second for s, Kelvin for k, candela for cd, ampere for a, and mole for mol. In physics, these 4 physical fundamental quantities we have to see in every chapter. Listen. What is the what is the formula of area? Do you know formula of
Length
area?
times width.
Length times width.
Sorry.
It depends on the
Length.
shape.
Area formula is length into breadth. So length we know, measure in meter, breadth also be a length, then it is also measure in meter. So these two are fundamental. These two are fundamental quantities, or this is a derived quantity. Whenever we multiply two fundamental quantity to form a derived, or whenever we divide two fundamental quantity, we can form a derived quantity. I think it's clear. What is
Can you explain one more time what breadth is?
Okay. Listen. For example,
1 second, sir. This is actually here, they call it width. So you do length and width, right, Mahi?
Oh, okay, yeah.
That's width. In Indian terminology, we call it breadth. So it's the same thing, width, length and width.
Oh, okay.
Go ahead, sir.
okay. For example, we have volume. There is formula of volume is length into width into height. Length we measure in the terms of meter. Width also measure in the terms of meter. Height is also measured in the terms of meter. So volume is the derived quantity, and these are the fundamental quantity. Whenever we multiply the fundamental quantity and form another or new quantity, that quantity is the derived quantity. Or whenever we divide the two fundamental quantities and form a new quantity that is also a derived quantity. Later, I have a question on the fundamental quantity. I think now it's clear.
Yes, sir.
Now, distance is a, now we start distance.
Before moving to distance, the units what he was explaining is the standard units. So sometimes you will have an objective that what is the standard units for that, and that's how
SI
you have to,
unit,
yeah, SI units. That's
standard
the
unit,
one.
international standard unit.
Correct. So when somebody asks that what is the SI unit for length, it will be always meter. The SI unit for mass will be kg. Time, even though here we have a different miles and other stuff, but these are the standard units in physics. So wherever it is, it will be always this one. Go ahead, sir.
Okay. Now, distance is a scalar quantity. And displacement is a vector quantity. Listen, suppose that there are 2 points A and B. We can travel from A to B from this path, and we can travel A to B from this path, and we can also move from A to B. Suppose that this path. Now we have 3 paths to move A to B. So we can move any path, use this or that. For example, if we move A to B and select this path, in this path there is a particular direction A to B. This is a displacement. And also a distance. But these two are distant. Displacement is the shortest path. Displacement is the shortest path. Displacement is depend on initial position and initial displacement depend on initial position and the final position. What is the initial position? From where we have to start. This is the starting point. So we call that initial position. This is the ending point. We call now final position. But displacement distance is the total path, total length of the path covered by an object, and distance does not depend on initial and final path. Distance not depend on initial and the final point. Final point. Whenever suppose that there is a boy, they move in this direction. Yeah, this boy select this path because it is the shortest path. Even it have a particular direction. Suppose that this is a 3 meter, or this is a 4 meter, and this is a 8 meter. So distance can move. A boy can move from this path, either this or either this. It means whenever we don't have a particular direction, or we do not depend on initial and the final position, then we call it is a distance. Whenever we call initial and the final position is fixed, and the distance between initial and the final position, the distance between initial and the final position is called displacement. I think now clear what is the difference between distance and the displacement. Yes or not?
Yes.
Yeah.
Listen, one more thing. We know that if a boy travel from A point to B point, A is the initial point and B is the final point. This path is displacement or distance. When we call displacement, when it depend on initial position or the final position. When we call a distance, they do not depend on initial